Harita, and today we are discussing about Floyd Warshall Algorithm. It is also known as all pairs shortest path algorithm. Using this algorithm, as the name suggests, we are going to find the shortest path between a pair of vertices. So if you consider this graph, so we are going to find the shortest path from A to all the remaining vertices. Same with the vertex B, C and D. So this algorithm is applicable for both directed and undirected graph. It is given by the formula Dij is equal to minimum of Dik plus Dkj comma Dij, where I comma j are the vertices and D is the distance between the vertices and K is the iteration value. So we are going to learn more further about this Floyd Warshall algorithm using an example. So this is the example that we are considering. So the first thing that we do is form a distance matrix D0. So how do you form this D0? So you have to remember 2 points. Since there is no loop between 1 and 1 or any direct edge between 1 and 1, so that value will be taken as 0. Similarly, all the diagonal elements will be 0. And if you have any direct edge between the vertices, you write the weight as the distance between the vertices. If there is no any direct edge, you take infinity as the distance between those vertices. So for example, from 1 to 2 we have a direct edge and that weight is 8. So we take 8 as the distance between the vertex. But from 1 to 3 we don't have any direct edge. So we take infinity as the distance. So this is the direct distance matrix. Begin with our first iteration, where we take the pivot value as 1. So that means the pivot column and the pivot row will be the constant, and we change the other values using the formula. So since the pivot value is 1, so first row and first column will be constant. So we write them as it is. And this diagonal elements also will be taken as 0. So because they won't change. So now we have to find second row and third column element. So we take D23 is equal to minimum of D21 plus D31 comma D23. Why we are writing D23 as 2 means maybe we may have direct edge, so we take it as D23 also we consider. So that will be minimum of, what is D21? D21 is infinity. So infinity plus something anyway will be infinity, and D23 is 1. So this minimum is 1. So we take it the same value as 1. Similarly, we find D24. D24 is minimum of D21 plus D41 comma D24. That is minimum of D21 is again infinity. So plus something, it's again infinity, and D24 is also infinity. So it's infinity only, it won't change. Similarly, we fill the rest of the values. So this will be infinity, so similarly using this formula and this iteration, we find the remaining iterations. So the number of iterations will be equal to the number of vertices. So we have k is equal to 1. So similarly we consider k is equal to 2, 3 and 4, and we find the last matrix D4. So similarly as told before, we do the second, third and fourth iterations. So using the same formula, for the second iteration we keep the second row and second column as constant because the pivot value is 2. So these are the changed values. Similarly for the third and fourth. So as you can see, as the iterations are increasing, so the infinite values are decreasing. So there are no infinite values when you come to the D4th iteration. So this D4 is the shortest path matrix for the given graph. So this is the Floyd Warshall algorithm. Thank you.